Welcome back, everyone. Today we're going to talk about section 3E. So first, I'm just going to show you the formulas, and then we'll get into using them with some examples afterwards. So if you have A sine theta plus B cosine theta, that's going to be equal to R times sine of theta plus alpha. We're going to get R by taking the coefficients. You do the square root of A squared plus B squared. In order to find alpha, we set tan of alpha equal to B over A, and alpha has to be in the first quadrant. So here you're going to make B over A positive every time, then do the inverse tangent of B over A to find your alpha. Now when we start with sine first, the sign in between is the same sign that I'm going to have here in my parentheses. If we start with cosine first, the sign here switches inside the parentheses. And it's always going to be R sine when I start with sine, and R cosine when I start with cosine. So here's our first example. It says express 2 sine theta minus 3 cosine theta in the form R sine of theta minus alpha. Since there's a negative in the middle here and we're starting with sine, we're still going to keep the negative over here. In order to find R, we'll take the square root of 2 squared plus 3 squared, which is the square root of 13, and you want to leave that in radical form. Very often, your R will be a radical. Now, in order to find alpha, we set tan of alpha equal to B. This is A is 2 and B is 3, to B over A. Taking the inverse tangent of 3 over 2, we find that alpha is 56.31 degrees. So to rewrite in this form, it's the square root of 13 times the sine of theta minus 56.31 degrees. Second part of the problem says, hence solve all of this is equal to the square root of 2. So they told us to find the simplified form, and this is what we'll set equal to the square root of 2. So that means the sine of theta minus 56.31 degrees is the square root of 2 over the square root of 13. Theta minus 56.31 is the inverse sine of root 2 over root 13. And that means theta minus 56.31 equals 23.09 degrees. Now remember, you have to find the other angle before moving anything that was inside the parentheses over. So for sine, it's going to be positive in quadrants 1 and 2. So to find the other angle, it's 180 minus 23.09, or 156.91 degrees. So to find theta now, I'll add 56.31 to both of these angle measurements and get my final answer of 79.4 degrees and 213.22 degrees. You're also going to be asked to find the maximum and minimum values of this type of equation. So the max value of A sine theta plus B cosine theta is the square root of A squared plus B squared. And the minimum value of A sine theta plus B cosine theta is negative square root of A squared plus B squared. And this will be true when the sine of theta plus alpha equals 1, and this will be true when the sine of theta plus alpha equals -1. Because for sine and cosine, the only range of values we can work with is between -1 and +1, and everything else is undefined. So the way we did this with sine here, we'll also do with cosine, as you'll see in the next example. The first part of example 2 is asking you to just rewrite this in the form our cosine of theta plus alpha, because it's starting with a cosine and there's a minus here, so the inside of my parentheses is going to switch to plus. A equals 2, A equals B, A equals 2, and B equals 1. So R is the square root of 2 squared plus 1 squared, or radical 5. The tangent of alpha is 1/2. So take the inverse tangent of 1/2, and alpha is 26.57 degrees. So to rewrite this in our final form, the square root of 5 times the cosine of theta plus 26.57 degrees. So the second part of the example asks you to find the maximum and minimum values and the values of theta at which these occur. So the maximum value is going to equal positive r, and the minimum value will equal negative r. In order to find the theta at which these occur, we have to set cosine of theta plus 26.57 degrees equal to +1 for the maximum, and set it equal to -1 for the minimum. The inverse cosine of 1 is 360 degrees. Or 0 degrees, but that would have given us a negative answer, and that's not in the range in which they're asking us. And the inverse cosine of -1 is 180 degrees. So now you simply subtract 26.57 from each side to get theta equals 333.4 degrees, or 153.4 degrees. So remember to keep posting questions from the homework that you want me to go over into that Google Doc, and let me know through that or Remind or email if you need any help. I'm always here. See you soon.